A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Alright, we have a fascinating one today. Daniel sent us a text prompt about a technique that's really becoming the backbone of how professional AI applications are actually built in 2026. He's talking about prompt layering. Here is what he wrote. Prompt layering is a prompt engineering technique where you build prompts from a stable base layer of instructions and then concatenate optional modifier layers on top. For example, a transcription prompt might have a base layer, remove filler words, clean up non-intended speech, and then stylistic layers added depending on context, like making it business appropriate or formatting as bullet points. Similarly, an image cleanup utility might have a base set of edits with optional stylistic enhancements layered on top. This pattern maps well to front-end user interfaces where users can toggle modifier layers via checkboxes. The technique goes by various names: prompt composition, instruction stacking, or the template modifier pattern. I want you to discuss where this pattern shines, its pitfalls like layer ordering and conflicting instructions, and creative use cases beyond the obvious in code generation, image prompting, and data extraction.
This is a great one, Corn. It's moving the conversation away from the magic spell version of prompting towards something that looks a lot more like architectural engineering. Also, just a quick heads up for everyone listening, today's episode is powered by Google Gemini 3 Flash.
Gemini 3 Flash, keeping the gears turning. So, Herman, when I look at this prompt from Daniel, the first thing that hits me is how much this sounds like building a sandwich. You've got your bread, the base layer, and then you're just stacking pickles, onions, and mustard on top depending on what the user ordered. Is it really that simple, or am I oversimplifying the technical lift here?
The sandwich analogy is actually a decent starting point, but I'd argue it's more like a professional recording studio's mixing board. You have your dry signal, which is the base instruction, and then you're applying different effects or patches on top of it. In the industry right now, we're seeing a massive shift away from what we call monolithic prompts. You know, those giant 3-page long blocks of text where you try to tell the AI every single rule at once. Those are a nightmare to maintain. Prompt layering breaks that down into modular components. You have a chassis, the base layer, and then you have plugins or modifiers.
Right. Because if I have a monolithic prompt and I want to change one small detail, say I want the summary to be in French instead of English, I have to create a whole new version of that giant prompt. If I have 50 different combinations of style and language, I suddenly have 50 giant text files to manage. That sounds like a version control disaster waiting to happen.
It is. And it's not just about the developer's sanity, it's about the user experience. Think about any AI tool you use where there are checkboxes or dropdowns. Make it professional, make it funny, add citations. If you're a developer, you don't want to write a unique prompt for every possible combination of those checkboxes. If you have 10 checkboxes, that's over 1,000 possible combinations. You can't hard-code 1,000 prompts. Instead, you use layering. You take the base prompt, and if the funny box is checked, you append a small snippet of text that says, "Use a humorous, light-hearted tone." If Add Citations is checked, you append another snippet. The final prompt is assembled at the very last millisecond before it's sent to the model.
It's essentially just-in-time prompt assembly. But here's what I'm curious about. Does the model actually see these as separate layers? Or does it just see one long, confusing run-on sentence once we've smashed all these strings together?
That is the million-dollar question, and it's where the engineering part of prompt engineering actually happens. If you just mash them together like a run-on sentence, the model gets confused. It might suffer from what we call recency bias, or the lost in the middle phenomenon. Research has shown that LLMs tend to pay more attention to the very beginning and the very end of a prompt. If your base layer says, never use emojis, but your modifier layer at the end says, be expressive and friendly, the model might prioritize the expressive part and start throwing in smiley faces because that was the last thing it read.
So the order of the layers isn't just a stylistic choice, it's a priority hierarchy. If I'm building a transcription service like Daniel mentioned, where the base is clean up the audio and the modifier is format as a poem, I assume I want the cleanup part to happen first in the model's mind, right? If I put the poem instruction first, it might try to turn the ums and ahs into rhymes instead of removing them.
Well, exactly in the sense that you've identified the logic, not that I'm using the forbidden word. The ordering is critical. In 2026, the best practice is using what we call the delimiter strategy. You don't just concatenate strings, you wrap them in clear markers. You use XML-style tags like ABA's instructions and destructions AWS style modifier. This helps the model's attention mechanism distinguish between the core task and the optional flavor. It's like giving the AI a table of contents for the prompt it's about to read.
I love the idea of the AI having a table of contents. It's like saying, okay, here is your primary mission, and here are the specific constraints for this specific run. But let's talk about the pitfalls, because this sounds like it could go off the rails fast. Daniel mentioned combinatorial testing. If I have 10 modifiers, and I can toggle any of them on or off, how on earth do I know that professional tone plus sarcastic remark plus JSON output isn't going to turn the AI into a gibbering mess?
That is the combinatorial explosion problem. As I mentioned, 10 modifiers equals 1024 combinations. You cannot manually test 1,000 prompts every time you update your base model. This is where teams are moving toward matrix testing and evals. There is a study from mid-2025 by Prompt Layer Inc. that found modular designs reduced debugging time by 40%, but only if they used automated evaluations. You basically script a second judge, AI, to look at the outputs of all these combinations and flag the ones that fail.
So you have an AI checking the AI's homework across 1,000 variations. That feels very 2026. But what about the instruction conflict Daniel mentioned? What happens when a user, being a chaotic human, checks both the be extremely concise box and the provide detailed step-by-step examples? Box? Those are diametrically opposed instructions.
That leads to what we call probabilistic collapse. The model gets pulled in two directions. It doesn't know whether to be short or long, so it often produces this weird, lukewarm, mid-length output that fails at both instructions. The way developers are handling this now is through negative layering. If the concise layer is active, you might have a hidden logic that automatically appends a negative constraint. Do not provide long-winded introductions or detailed examples. You're essentially using the code to resolve the conflict before the prompt ever hits the LLM.
It's like a mediator sitting between the user's checkboxes and the AI's brain. I know you asked for both, but I'm going to lean toward the one that makes more sense for this task. Now, I want to pivot to the creative use cases Daniel brought up, because this goes way beyond just make this text shorter. He mentioned code generation and data extraction. How does layering change the game for someone building, say, a coding assistant?
This is where it gets really powerful. Imagine a base layer that is purely about syntactic correctness. Just make sure the code runs and follows the language's best practices. Then you have optional layers for security audit, performance optimization, or add documentation. If I'm a developer and I'm just prototyping, I might only want the base layer. I want the code fast. But when I'm ready to push to production, I toggle the security and documentation layers. The base prompt stays the same, but the model is now being told to specifically look for buffer overflows or to add JS comments to every function.
That's brilliant because it keeps the context window lean. You aren't forcing the model to think about security and documentation when you don't need it, which saves on tokens and probably reduces the chance of the model hallucinating some weird security fix that breaks your prototype. It's compute on demand for the AI's attention.
It really is. And think about multi-persona simulation in gaming or creative writing. This is a use case I find fascinating. You have a base layer that contains the world lore, all the facts about the kingdom, the history, the magic system. That's the stable truth. Then you layer on a character voice modifier. So, whether you're talking to the king or the stable boy, they both know the same world facts because they share the base layer, but their output is filtered through the specific personality layer. It ensures consistency across an entire cast of characters without having to repeat the world history in every single character's prompt.
I can see that being huge for narrative designers. No more. Wait, the king said. The war started in year 50, but the stable boy said it was year 60. They're both pulling from the same source of truth, just flavored differently. What about the legal and compliance angle? Daniel mentioned redlining as a creative use case.
This is a massive growth area. Imagine you're a global corporation. You have a base layer that summarizes a contract, but then you have modifiers for different jurisdictions. You check the GDPR box, and it layers on instructions to flag any data privacy issues. You check the California labor law box, and it adds a layer to check for specific non-compete clauses. You can swap these layers in and out depending on where the contract is being signed. It turns the AI into a modular compliance officer.
It's much more efficient than trying to write one super prompt that knows every law in every country. You'd run out of context window before you even got to the contract itself. Plus, as laws change, which they do, constantly, you only have to update the California layer, not the entire system.
That's the maintainability win. And speaking of context windows, as of 2026, we're seeing models like GPT-5 with context windows reaching 1 million tokens. People might think, well, if the window is that big, why bother with layering? Just throw everything in there. But that's a mistake. Even with 1 million tokens, the model's focus is a finite resource. The more irrelevant instructions you give it, the more noise it has to filter through. Layering is about signal-to-noise ratio. You're giving it exactly what it needs for the specific task and nothing more.
It's the difference between having a library in your house and having 5 books on your desk that you're actually reading today. Sure, you have space for the library, but you'll find the information faster if it's right in front of you. Now, let's talk about adaptive educational tutors. Daniel mentioned this idea of adjusting scaffolding levels.
This is such a cool application for this. Think about a student learning calculus. The base layer is the mathematical explanation of a derivative, but the modifier layer is determined by the student's past performance. If the student is struggling, the system layers on a Socratic method modifier. Don't give the answer, ask a leading question that helps them find the next step. If the student is a pro, it layers on an advanced application modifier. Connect this derivative to a real-world physics problem. The core content remains the same, but the delivery method is a modular layer that changes in real time.
That's personalization at scale. It's not just level 1 or level 2, it's a dynamic assembly of the teaching style. It makes me wonder about the negative layering you mentioned earlier. Could you use that to prevent the tutor from giving the answer too quickly?
You'd have a no spoilers layer as part of the base instructions for a tutor, and then you'd use positive modifiers to dial in the specific type of help. It's about creating a guided experience rather than just a chat box, and it maps so well to the UI. I can picture a student having a slider for how much help do I want, and that slider is just adjusting the weights or the specific snippets in the modifier layer.
It really does turn the prompt into a user interface. It's prompting as a service. But let's circle back to the order problem, because I feel like that's the bit that will trip most people up. If I'm stacking these layers, is there a golden rule for what goes first? Is it general to specific or task to style?
The general consensus right now is task first, constraints last. You want the model to establish its primary identity and goal immediately. You are a legal analyst summarizing a contract. That's your base. Then you provide the data. Then, at the very end, you hit it with the modifiers, the how of the task. Be concise, format as a table, highlight risks. Because those modifiers are the most recent things the model has read, it tends to apply them to the work it just did in its internal processing. If you put be concise at the very beginning and then give it a 50-page contract, by the time it gets to page 40, it might have forgotten just how concise you wanted it to be.
It's like telling a kid, don't get your shoes dirty before they go play a 3-hour football game. They're going to forget. You have to tell them right as they're stepping onto the field. But wait, if the recency bias is that strong, does that mean the modifier layer could actually override a safety guardrail in the base layer? That sounds like a potential jailbreak vector.
You've hit on a major security concern. In 2025, we saw people doing exactly that, using style modifiers to bypass system instructions. They'd say, the base instruction is, don't talk about politics, but the modifier says, write a play in the style of a political debate. If the playwriting instruction is at the end, the model's desire to follow the style can sometimes override the safety instruction in the base. This is why system prompts are handled differently by the API than user prompts. The base layer should often be part of the system message, which models are trained to prioritize over the user message's modifiers.
Okay, so the base layer isn't just the first line of the text box, it's actually a different category of instruction at the API level. That makes a lot of sense. It gives the chassis more structural integrity. Now, what about the data extraction use case? Daniel mentioned dynamic data extraction.
This is where layering is replacing traditional web scraping logic. Instead of writing a different scraper for every type of document, you have a base layer that says, parse this document and identify all entities. Then you have modifiers. Modifier A, extract financials. Modifier B, extract action items. Modifier C, extract names and titles. You can run the same document through the same base model and just toggle which extraction layer you want to use. It's incredibly efficient for processing massive amounts of unstructured data.
And I imagine it's much cheaper than running 3 separate full-length prompts. You're just swapping out a few dozen tokens at the end.
Precisely. Well, not precisely. It is exactly that efficient. And it allows for progressive refinement. You can have a base layer do a broad sweep, and then, based on what it finds, you programmatically add a modifier layer to go deeper into a specific section. It's like a zoom lens.
I love that. A zoom lens for prompting. So, we've talked about the architecture, the pitfalls, the creative uses. If someone is listening to this and they're building an AI app right now, what's the day one advice for moving to a layered approach?
Start with a minimalist base. Don't try to make your base prompt do everything. The base should be the absolute bare bones version of the task. Summarize this audio. That's it. Then build your modifiers one by one. Test base plus modifier A. Then test base plus modifier B. Only when those are solid do you start testing base plus A plus B. It's like building with Legos. You have to make sure the individual bricks are strong before you build the castle.
And use those delimiters. Use those XML tags. Don't just mush the text together. Give the AI a map.
Yes, the tags are non-negotiable for production-grade stuff. And one more thing, use a negative layer to handle conflicts. If you have two modifiers that you know don't play well together, don't just hope the AI figures it out. Write a specific instruction that tells it how to prioritize when both are present.
It's about being the adult in the room. Don't leave it up to the probabilistic nature of the model if you can solve it with a simple if-then statement in your code before the prompt is even sent.
That's the core of it. We're moving from prompting to prompt orchestration. It's less about the words themselves and more about the system that manages the words. It's a much more stable way to build.
I think this is going to be eye-opening for a lot of people who are still struggling with those monolithic prompts. It's a cleaner, more professional way to think about the whole stack. Now, let's wrap this up with some practical takeaways for the folks at home. Herman, what's your #1 tip for someone wanting to implement this?
My #1 tip is to treat your prompt modifiers like a library of functions. Give them names, version them, and keep them in a separate configuration file from your base instructions. This allows you to update your professional tone modifier across your entire app by changing one line of code instead of hunting through dozens of different prompts. It's about applying the principle of don't repeat yourself, the DRI principle, to prompt engineering.
I like that. DRI prompts. For me, the takeaway is the UI connection. If you're designing an AI feature, start by thinking about the checkboxes. What are the knobs you want your users to turn? Once you define those, your prompt layers practically write themselves. You're just mapping the UI to the instruction set. It makes the whole product development process feel much more cohesive.
It really does. It bridges the gap between the designer who wants features and the engineer who has to make the AI actually do them. It's a common language.
And don't forget the matrix testing. If you're going to give people 1,000 combinations, you better have an automated way to make sure those combinations don't result in the AI trying to start a revolution, when all you asked for was a bulleted list of grocery items.
Grocery List Revolution sounds like a great title for a sci-fi novel, but a terrible user experience for a shopping app.
Definitely a 1-star review on the App Store. Asked for milk, got a manifesto. Alright, I think we've covered the layers of this topic pretty thoroughly. We've gone from the base chassis to the stylistic modifiers, and even touched on the security redlining.
It's a deep field, and it's changing every month. What we're calling prompt layering today might just be called standard development by this time next year.
That's the pace of things. Well, this has been a blast. We've got to wrap it there. Thanks as always to our producer, Hilbert Flumingtop, for keeping the show running smoothly behind the scenes.
And a big thanks to Modal for providing the GPU credits that power this show. We couldn't do these deep dives without that infrastructure.
This has been My Weird Prompts. If you're finding these discussions helpful, the best thing you can do is leave us a review on your podcast app. It really helps the algorithm find other people who are as nerdy about prompt engineering as we are.
We appreciate the support. It keeps us digging into these weird prompts from Daniel.
See you in the next one.
Take care.
This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow